Yeah, good morning all. Myself, Mr. PV Gopi Kumar, working as an assistant professor in the Department of Electronics and Instrumentation Engineering. Now, I would like to tell you about realization of the FIR and IIR filters with suitable structures. Now, let us see. If impulse response of the system is a finite duration, then the system is said to be FIR filters, and if the impulse response of the system is of infinite duration, then the system is said to be IIR filters, infinite impulse response filters. To realize those filters, we have different structures. Let us say, for example, first one is direct form 1 structure, and second one is direct form 2 structure, and third one is cascade form, and fourth one is parallel form. Before analyzing the filters with these suitable structures, first you should know about what are the basic elements will be utilized to implement these filters with the different kinds of structures. And also, before going to discuss about basic elements will be used for implementation of the filters with the suitable structures, you should know about the system function. Once you know the system function, then later we will discuss about the basic elements utilized to implement the filters with suitable structures and different kinds of forms, how the system function will be implemented. So now first we see system function. System function is nothing but transfer function. Transfer function here in digital signal processing, we can define it as Z transform of the output by Z transform of the input is nothing but system function, and which is denoted with H of Z. So mathematically it can be written as Y of Z by X of Z. Now we see the system function to implement these filters. This system function will be defined as H of Z will be equal to sigma k equal to 0 to m bk z power minus k by 1 plus sigma k equal to 1 to n ak z power minus k. So this is the system function to define the any filter, and by expanding this system function, and you can implement this system function in various forms. Those forms will represent any one of the structures, that is direct form 1 structure, direct form 2 structure, cascade form, or parallel form. So what it means, a single function, system function H of Z is expressed in different possible ways. That is, H of Z can be implemented by using one equation, can be implemented using two equations, and that H of Z, the complete system function will be partitioned and implemented with the product of the subtransfer functions. And also one more possible form can be implemented by using sum of partial subtransfer functions. So based on the representation you are writing, it forms the different structure, form 1, form 2, or cascade, or parallel form. So first, to implement this system function in different possible ways, first we see the basic elements of the block diagram to represent any filter with the suitable structure. Later we expand this system function equation and we will draw the different structures like direct form 1, direct form 2, cascade, and parallel. So first we see elements of basic elements of block diagram. Basic elements of block diagram. These are the basic elements. If you know these basic elements, then only it is possible to draw the different realization of the suitable structures of the FIR and IIR filters. So first we will classify this block diagram as basic elements of block diagram, and next one is time domain representation, and next important classification is frequency domain representation. So here we will see basic elements and how they can be implemented in time domain representation and how they can be implemented in the frequency domain representation. Next, we will construct the block diagram. So first basic element of the block diagram will be adder, and second one is constant multiplier, and third one is unit delay element, and fourth one is unit advance element. So these are the basic elements of the block diagram. Next we see how adder, constant multiplier, and unit delay element and unit advance element will be implemented time domain representation and frequency domain representation. So for considering the first basic element adder, so there we have the let us consider two signals x1 of n and second signal is x2 of n. So these two signals to be added, and the output of the signal in time domain representation will be x1 of n plus x2 of n. So this is output in the time domain representation. Similarly, if you see the frequency domain representation, frequency domain representation of the x of n signal will be x of z. So x1 of z is the first signal and second signal will be x2 of z. If these two signals to be added will give you the x1 of z plus x2 of z. So this is the output in the frequency domain representation. Next, constant multiplier. Let us say x of n be the input signal and constant multiplier will be the a, and the output of the signal will be represented in the time domain representation will be a into x of n. Similarly here the signal will be x of z and constant multiplier will be taken as a, and here the output of the signal in the frequency domain representation will be a into x of z. And next we take unit delay element. So as usual input will be the x of n, unit delay element will be represented by z power minus 1, and in the time domain the output of the signal will be represented by x of n minus 1. This is the important. And in the frequency domain representation how it will be implemented is x of z will be taken as the signal, and here z power minus 1 is the unit delay element. So output of the signal in the frequency domain representation will be z power minus 1 into x of z. Somewhat this is simple when compared to the time domain representation. Now we take the final element, a unit advance element. As usual x of n will be the input and unit advance element will be z power 1, and the signal here the output is x of n plus 1. Why it is called unit advance element means, so initially let us say if the signal is getting started at n equal to 0, now it is x of n plus 1. So n plus 1 equal to 0 implies n equal to minus 1. So now the signal is getting started from minus 1 onwards. So the signal is getting advanced. So that's why it is called as advanced element, and this is the representation in the time domain. And now we see the signal, how it will be represented in the frequency domain representation. So x of z and unit advance element, and the output will be, as you know, just write earlier, z into x of z. So these are the basic important elements, z into x of z. So like this, these are the basic elements we required to construct the block diagrams to represent the FIR and IIR filters with suitable structures. In next session, we will discuss about the structures and how to construct the block diagrams of the FIR and IIR filters using the variable realization forms. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.